Hi everyone. Today I will be going over the algorithm called You Only Look Once, or YOLO for short. And this model is highly efficient and accurate in real-time object detection. Now, when I say object, your objects could be anything. Today's example, however, will be on animal behavior tracking, or in today's specific example, just animal tracking in general. Many times in experiments, we don't always need pose estimation. Sometimes we just want to know how fast is an animal moving, or where is the animal going, what area is the animal spending most of its time in, and those type of things. So for those applications that don't need pose estimations, YOLO is very, very efficient and very accurate. So I will be showing you how to download and train the model, how to label and annotate images so you can train the model and then utilize it to detect animal movements in real time or in recorded videos for your custom data set. And you can follow along in this tutorial and utilize it for your needs. Okay, I'm going to create an Anaconda environment. In my case, I'm going to label my Anaconda environment YOLO V8, and that the V8 designation is the model that I'm going to be using. The next task is to extract frames from the video that I'm going to utilize to provide my model with some training data. Over here, you can designate how many frames you want to extract, the FPS of your video, and the file name in the input. Here I forgot to give it the input file name, so I'm just going to copy the title of my video that I want to extract the frames from. All right, perfect. So the frames have been extracted. Next, I'm going to create a couple of new folders and move my extracted frames into those folders. So let's create a new folder, title it Images, and move all of the extracted frames inside of that folder. Let's make another folder and call that Labels. And then next we need to download a library to annotate our labels. So I'm going to copy paste pip install label img, I is capital. And to bring up the annotation tool, you simply have to type in label img with capital I. Let's open the images, the directory for the images. And before I move on, let's save this directory and let's save it into a new folder. And that folder is going to be called Labels, and this is where all the annotation are going to be saved. Make sure you have this saying as YOLO, and you can make your annotations using this rectangular tool. Alright, after you're finished annotating your data, just make sure that your data is there, save it and close it, and install Ultralytics. You can type in pip install Ultralytics. I misspelled ultra. And just install that. And then we need to install PyTorch. And the code is in the description if you need to install this. Next, let's create a couple of new folders. One folder is going to be called train. The other folder is going to be VAL. And I'm going to move my images and labels folder into my train folder. And from my train image folders, I need to move some of the images to the VAL folder. And these will be utilized for evaluation of the model. So under the val folder, I'm going to create another folder called images and paste my images into the val folder. And then same thing for the labeled folder. So take the corresponding labels and make a new folder under the val folder and put the labels for the corresponding images that you want to utilize for evaluation of your model into the labels in the val. Next, let's make a YAML file, and this is going to have some instructions. And I'm calling it data_custom.yaml. You can call it whatever you want. Just make sure that you have the extension YAML. So we need to provide path to the training folder. Here I'm copying the path and pasting it in. Make sure you get rid of any quotation marks. Then this is for the path to the val folder. And then the NC is the number of classes. I'm only using one class, and the name for that is mouse. So it's a fairly easy training scheme. And then once you have that YAML set up, you can go ahead and copy the next code and paste that. Here I'm going to be using batch size of 8, and this just helps limit the GPU memory usage. It prevents the GPU from getting too burdened. Now to find the model that you need to use, you can just Google YOLO V8 and then go to the GitHub page, scroll down to where they have the models. So under the detection, there copy the link to the and then paste it into a browser. And then at the end, this little bit is the name of the model. So I'm using V8M, which is a medium-sized model, and it was trained on image size 640, and I'm using batch size as 8. This will help limit the GPU memory usage. The epochs you can utilize anywhere from 100 to 1000. Generally, the training will stop whenever 100 epochs, the confidence are stable for 100 epochs. So the training will automatically stop. Okay, so the training is going to take some time, and I will pause the video and come back once it's done. Okay, my training has finished. So now I'm going to just copy one of the videos that I have on an external hard drive, and I'm going to copy this into the folder that I was previously using, the root directory. I'm going to utilize the this as the source to pass it to Ultralytics, or YOLO in this case, and have it predict the objects that it finds. So in my case, it should find the mouse that I have in all of my videos. here I need to give it the source. Source is the name of the file that I wanted to analyze. So this is a video that the model has never seen, and I want to see how good it performs on this model. Sorry, on this video. The model itself, the trained model, is inside runs, detect, and then the weights, and you can just copy this best.pt out into your root directory and utilize it directly from there. So I'm going to rename it to OFT open field underscore model, and this will just help me understand what the model was trained for. Okay, so I'm going to copy this snippet of code and paste it, and then let's run and see how good it's doing. So for this particular video, it's not doing so well. I can potentially improve this by giving the model some more data to train on and more variation of gradients. Let's try another video. So for this video, the model is actually doing pretty good. Now you can save the confidences and also the bounding box information by setting one of the parameters to true, and that way you have the bounding box x and y coordinates. And for some people that might be useful, you can utilize those to analyze your videos further. Okay, so that's it for this tutorial.